Now we've alluded to planes, but let's make everything really specific, okay? Now, just as an example, I'm going to say the plane through 5, 9, 6, perpendicular to n equals 7i minus 5j plus 8k. Now that just happens to be the same as the vector v that characterized this line. So what we're actually doing is we're going to find a plane that's perpendicular to this line. A plane through this point perpendicular to this vector, and I use n here instead of v because now this is called the normal vector. The vector normal to the plane, the vector perpendicular to the plane. That plane consists of all the points x, y, z with the property that the vector from 5, 9, 6 to x, y, z is perpendicular to that normal vector. Now you should be able, based on what you know and what you've also seen in the earlier videos posted for this class, you should be able to easily write down that condition and that plane, because this is phrased in a way that's almost identical to the way a problem in the document was phrased. So you should probably stop and do that. It's recommended, but I'm going to go ahead. So hopefully you've stopped and done it. If you did and did it successfully, you'll understand it much better. So let's see now. What do we see here? We see mention of the vector from 5, 9, 6 to x, y, z. What do? We draw a point here that's 5, 9, 6. We draw a point here, call it x, y, z, and here's our vector. Okay? And let's go ahead and call this vector. I don't want to call it v because it might be confused with this v here, so I'll just call this w, but this is any vector because x, y, z could be any point at all. Now we're trying to get the condition that has to be met for the point x, y, z to lie in the plane that we're trying to find. But right now, x, y, z is just any old point. 5, 9, 6 is the given point, and w is the vector with initial point 5, 9, 6, terminal point x, y, z. And w is then the vector x minus 5i plus y minus 9j plus z minus 6k. Well, in order for this vector to be perpendicular to n, see now we've got this vector, right there it is, okay? And it says this vector is perpendicular to n. Okay, so I'll say that w perpendicular to n, what's the condition for w to be perpendicular to n? You should stop and think for a minute. Don't wait for me to say it, or don't keep going so that I say it and you don't have to think it. Pull this out of your memory. That's how you begin reinforcing, and that's how these ideas begin to become second nature to you. Okay, well, it should be second nature that two vectors are perpendicular if the dot product is 0. And that is, well, w dot n, and I'm not even going to write that out, I'm just going to do the dot product, x minus 5 dot 7, oh well, this vector dot of this vector. X component or I component times I component is 7 times x minus 5. J component times J component is negative 5 times y minus 9. And K component times K, if I could talk, K component times K component is x times z minus 6. That should equal 0. Okay, well that's equivalent to what? 7x minus 5y plus 8z. And then the numbers that we get. Negative 35 plus 45, that's so far 10. And negative 40, which is minus 30. And if I did that correctly, this is the relationship that x, y, and z have to satisfy this, or an equivalent, we could multiply or divide this by the same quantity, but this or the equivalent is an equation that has to be satisfied by x, y, and z in order for x, y, and z to lie on this plane. And also, if x, y, and z satisfy this, then that point has to lie along a vector from 5, 9, 6 to that point perpendicular to our specified normal vector. In other words, the point would have to then lie in the plane. So this completely characterizes the plane. Now, just as a quick check, let's make sure that 5, 9, 6 works. If we do 5, 9, 6 and add, use 5, 9, 6 for our x, y, and z, what we get had better be 30. If it isn't, we're going to have to fix something. Okay, well, 5 times, and I don't know if it's going to work out or not. I did these calculations at the top of my head. So 5 times 7 is 35. 9 times negative 5 is negative 45, so that's negative 10. And I've got a problem here because this is wrong. 8 times 6 is not 40. 8 times 6 is 48. So I caught myself in an error. Okay, well that's negative 48, so I guess this has to be negative 38. And let's see if that works. Okay, again, 5 times 7 is 35. 9 times negative 5 is negative 45. That gets us to negative 10. 6 times 8 is 48. Negative 10 and 48 is 38. And 38 minus 38 is 0, and now it works. Okay? Now the calculations I did here, the 7 times 5 and the 5 times 9 and the 8 times 6, should be familiar to you because we just did them up here as part of the distributive law. And you should then see a little more clearly what's actually going on here. So here's the equation of our plane. Now I'm going to kind of generalize this, and I'm just going to take some of the numbers out here and put in some symbols to replace some of what I have, and you'll see maybe a little more clearly. Well, let me not actually do that. Let me say, okay, what if this point was x naught, y naught, z naught instead of 5, 9, 6? Okay, and what if this is ai plus bj plus ck? What does that change? Well, of course, 5, 9, 6 will now be x naught, y naught, z naught, and n will be ai plus bj plus ck. So that takes this point here. This becomes x naught, y naught, z naught. This point is still x, y, z. Now this x minus 5 here becomes x minus x naught. And the y minus 9 becomes y minus y naught, and the z minus 6, I'm going to have to put it up here, becomes z minus z naught. Then our dot product becomes what? Well, the normal vector is ai plus bj plus ck, so that instead of this, we're going to get, and I'll write it all out, ai plus bj plus ck, hopefully I'm out of the way there, dotted with x minus x naught I plus y minus y naught j plus z minus z naught k. That's going to have to equal 0. And of course, the equation is a times x minus x naught plus b times y minus y naught plus c times z minus z naught has to equal 0. This is a dot product of two vectors that have to be perpendicular. So that our equation in general is just a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. We see that in this equation the coefficient of x is always the coefficient of I on our normal vector. The coefficient of y is always b, which is the coefficient of j. C is always the coefficient of k. And instead of x, we got x minus x naught, y minus y naught, z minus z naught. Now when we distribute through this thing, we'll have ax plus by plus cz instead of the specific calculation 7x minus 5y plus 8z, which tells us that our normal vector is 7I minus 5j plus 8k. We can just read that off. And then our a times negative x naught and our b times negative y naught and our c times negative z naught are going to add up to a number that will be there in place of the negative 38. Okay, and that's the equation of a plane, and you can see how the equation of a plane is related first to the normal vector and second, a little more subtly, to the point specified. And of course, if we want to find a point on the plane, if we just pick a value of x and y, we can solve for z. So we pick any x and y on this plane and solve for z, and now we've got a point on the plane. So in particular, as we've done before, we can let x and y equal 0, and we find that z would be what? 38 over 8, which is 19 over 4. So z is 19/4 when x and y are 0. That gives us a point on the z-axis. And if x and z are 0, we solve the remaining equation. We get the value of y, and that gives us the coordinate at which the plane intersects the y-axis. And similarly for z, let y and z be 0, and we get the point where, or the coordinate where we cross the x-axis, and we get our picture, and I'll just draw that picture and ask you to look at your book, which has a similar picture, and look back one class at the video where we did this if necessary. Okay, but hopefully you've already got that idea. Okay, so this whole section's on equations of lines and planes, at least the homework that's assigned from today. So good luck on that, and let me know if you have questions.